Welcome to our introduction to inverse functions. All right, so first we're going to be looking at this function f of x equals 2x plus 4. This is a linear function, right? If I plug in numbers for x, I get out numbers for y, right? F of x, I'm going to use salmon here. F of x is equal to y, right? Let me make that a little clearer. F of x is equal to y, okay? So I've got a y equals some sort of function in terms of x, okay? So if I were to plug in f of 2, I get 2 times 2 plus 4, which is 8, right? I could plug in another x, which let's say I plug in f equals 3, all right? So 2 times 3, I'm going to actually change these to parentheses. 2 times 3 plus 4, that gives me 10, all right? So what I'm working with here is I have my domain, and my domain has all of those numbers that I'm plugging in. 2, 3, all right? It also has everything else that we could plug in to our function here for x, all right? I'm also working with a range of numbers. The shape is unimportant. Range of numbers, which are the numbers that come out. They're the y's, right? Domain, we always talk about as being x, range as y, right? So my range of numbers contains 8 and 10, all right? And notice that our function is built to map 2 to 8 from our domain to our range. The function maps 2 to 8. Also, our function maps 3 to 10, right? So that's what the function is doing. It is mapping each of those from the domain to the range, all right? But what if there was a function that mapped our numbers that are contained in the set in our range to the domain? What if we had a function that took 8 back to 2? Oh, sorry about that zoom issue. That took 8 back to 2, or that took 10 back to 3. Right? Now, what we call this would be an inverse function, okay? An inverse function is not the opposite. It is not the reciprocal of anything. We are just mapping back from our range back to our domain, okay? That's our inverse function. And we notate that with f to the negative 1. All right, that's how we notate an inverse function. So let's look at how we would find the equation of the inverse function. All right, so we have our function f of x equals 2x plus 4. Okay, f of x equals 2x plus 4. Well, like we talked about before, that could be written as y equals 2x plus 4, correct? Now remember, domain and range, domain we can see as being our x's, and range see as our y's for our original function. But now that we are trying to find the inverse function coming back this direction, that means our range is now our x's and our domain is our y's. The domain and range have flipped. We have a new domain and a new range. So what I'm going to do is I'm going to take my x and y from my original function, and I'm going to flip them. X equals 2y plus 4. Now, I'm just going to solve for y, because I want to know what y equals in this new equation, in this new function. So I would subtract 4 from both sides, so I would end up with x minus 4 equals 2y. I can then divide by 2, and I'm going to get x over 2 minus 2 equals y. So I have y equals x over 2 minus 2 as a new function. This is what we would call f inverse of x. F of x was our original one, 2x plus 4. F inverse of x is x over 2 minus 2. So f of x maps everything from this set of numbers to this set of numbers. the inverse function, f inverse of x, maps everything from this set to this set. We have switched our domains and ranges between those two between those two functions. Okay, so let's look at how the graphs of these functions are related to their inverse relations. Okay, so let's start with f of x, which is 2x plus 4. All right. So it has a y-intercept of 4. It's a linear function. It's got a slope of 2. We've got a graph that's doing something like this-ish, right? Yeah. So this is the graph. Maybe I'll try to make that a little bit thicker for you guys so you can see it. All right. This is f of x, which is equal to 2x plus 4, right? Now, our inverse function is x over 2 minus 2. It has a y-intercept of negative 2, and we have a slope of 1/2. So we're something like this. Oh, that wasn't a very good. Let's see if we can move that. Yeah, we'll call that good enough. And I'll try to make that a little bit thicker. Okay, so we've got f inverse of x. All right. So this function takes us from x world to y world. This one goes the opposite, right? But we just flip those domains and ranges, so we actually still have x and y. Notice these are kind of related. They almost look like they've been reflected over something. And if we were to draw the line x or y equals x right down the center, that line is what the inverse the function has been reflected over to become the inverse function. All right. So all that's happened is our x's and y's got flipped. One of them is going to map from x's to y's. The other one maps the other direction. Okay. Let's take another example. Let's look at f of x equals x squared. So in this case, I have y equals x squared for my original function. If I want to find my inverse function, I'm going to switch my x's and my y's. So now I am going to have, well, let's solve for y again. I'm now going to need to take the square root. So I have plus or minus the square root of x equals y. If we flip that around, I have y equals plus or minus the square root of x. All right, so now to graph them, this graph's a little far down, that's okay. Y equals x squared, we know how to graph. Got something kind of like this, right? I don't know why that's not graphing right there. All right, and like this. A little more there. Okay, that is our f of x, which is equal to x squared, right? We also have our inverse function, which is going to be something like this. Sorry, our inverse relation. I should not have said function, and I will say that. I'll say y in a second. Inverse of x is plus or minus the square root of x, right? Now, these have as well, just like we saw, have been reflected over the line y equals x, okay? But notice that the range of f, the range of this function, is 0 to infinity, yes. The range of f, let's see, so f of x has a range with y being greater than or equal to 0, right? We don't ever go down here, we're always up here with y or with f of x. Its domain is all real numbers, right? Because it goes all the way this direction and all the way this direction. If we look at the inverse relation, which I probably shouldn't have written this way, we'll write it as y equals. and it's the inverse of f. It, notice, is not a function. A function must pass the vertical line test. If I have, let me just take a dotted line here. Okay, we'll do this a little better than that. Dotted line, perfect. So if I take this dotted line and move it across, I only am ever intercepting my function, the salmon-colored one, once. For every x, there is one y. But notice when I get to the purple one, the inverse function, I start intercepting twice at a time, right? See how I have 2 points here where I'm intercepting this vertical line? For 1x, I have 2 y's. In my map, from my domain to my range, I have 1x that maps to the same y, and a function cannot do that. So my inverse of f is not a function. All right, but the inverse relation would be graphed as so.